Monday. Hey, throw me an emoji or a GIF or something in live chat. Just let me know how you're feeling. Let's wake up fingers. Just try and break out of that weekend mode. How are things? How's your weekend? What are the vibes now? I bet everyone's choosing a really good GIF. That's probably what's going on. Gotta find the perfect one. Excellent. Thanks, Dragosh. That's cracking me up. All right, how about the rest of y'all? How are things? Anything fun with your weekend? Any feelings going into this week? Man, the This Is Fine dog should really just be like a mascot for every class. Everyone's always pulling that out. Anything else? Folks awake? If you're sleeping, you legally have to tell me. It's part of the different documents you signed to join the class. All right, well, good morning, Rakesh. Whatever time it happens to be. All right, we got a few other folks starting to chat. I'm not just pestering you for my health, I promise. I do just also want to know that the folks are here, feeling good. All right, congrats, Chris. Friday can't come soon enough for you. All right, excellent. Let's go ahead and get started. Thanks for weighing in there, y'all. Go ahead and share my screen over here, and we can take a look. So today, as discussed, we're going to talk about loops and iterations. So just sort of recap what we've done so far. So remember now what, 2, 3 weeks ago, we started on JavaScript. There we were really talking about the syntax, learning about how to declare variables. What are we doing with these equal sign or the semicolons, right? So we're just sort of getting our feet wet. Then this past module, this current module, we've been talking about how to control the flow of our applications. So we've been talking about conditional statements. We've been learning about how to compare different values with greater than, equal than, strict inequality, strict equality, things like that. Today we're going to talk about loops and iteration, which is another way to control the flow of our application, another tool in our toolbox of how to tell our computers what we want them to do to design our programs. I'll say at the outset, this is can be a challenging one. In some ways, you're really going to have to start to get your brain thinking like a computer thinks. So I'll make sure we go through this as slowly and confidently as possible, but please do let me know if you all have questions or if anything feels like, yeah, it makes sense right now when you're saying it, but it's not going to make sense later. If you have a feeling like that, like you're just sort of tenuously holding on, please let me know so we can dive a bit deeper into it, because this is definitely something you can feel like you're going to get left behind on if you're not paying attention. But with that said, I think it's one of this is another sort of big level up for you all and be able to write your programs. Once you have iterations in your tool belt, you're gonna be able to build all kinds of really fun programs. And this is actually what I would say is like one of the key tools you'll need if you want to like build a little game in your terminal, if you want to build kind of like any kind of like running program, this is the tool you'll need. All right, so let's go through the overview. So in this lesson, you'll dive into loops and iteration in JavaScript. You'll learn about while and for loops and how to use them to repeat actions in your code. So by the end of this lesson, we're hoping you'll be able to implement while and for loops and understand when to use each type of loop. That is the plan for today. As you can see over on the right here, we got a number of different topics to go through. We're going to talk about for loops, which is one particular type of loop. We're going to talk about while loops, another particular type of loop. And then we're going to talk about the break keyword and how to use nested loops overall. So that is the plan for today. All right, let's go ahead and get started with our warm-up question. So not so much a quiz question, so much as a discussion thinking question. So consider your typical day from start to finish. Just for you all, are there certain activities or tasks that naturally lead to the next, creating sort of rhythm or pattern in your routine? Or how would you describe the flow of your day? And are there particular moments that influence the sequence of your activities? I think this question is really trying to get at, like, what are some of the patterns that you all follow in your everyday life? For example, some folks have a strong feeling over whether or not they should be brushing their teeth before they have breakfast or brushing their teeth after they have breakfast. This is what I've heard in the past. So are there any sort of like daily routines that you all go through every day, and you just find yourself, sort of it's part of your natural rhythm? What do y'all think? As you all are typing, I'll give another example here. My very lovely dog, who sometimes barks, is precise with the patterns. Like, he knows exactly when we wake up, when he needs to go to his chair, when it's time for him to go out and get his food. He's much more ritualistic than myself and my partner. So it's very on top of it. Ravish, I agree, but I don't know. I've heard different things from folks. It's I don't know. People have strong opinions about things. How about the rest of y'all? Any particular patterns you all follow into? Another one I feel like folks will. Oh no, Omar, I'm so sorry. How about this? Does anyone shower in the morning versus shower at night? Some folks feel really strongly about those kind of things. Like, why would you shower in the morning when you're like all gross at the end of the day? You want to shower at night? Any strong feelings there? Yeah, all right. All right, all right. No patterns. Y'all are just little chaos gremlins. Every day is new and different. I mean, hey, if it works for you, that's a-okay. Uh yeah, so what I'll say is I think what this is trying to get at here is that in regular life, we have some routines that we'll regularly follow. It might be sort of the order in which you do different chores or sort of different upkeep for yourself. Uh, in other aspects, it might be even when you head to work, sort of what you do at first, what your day-to-day looks like. Whenever we're talking about programming, particularly with something like with JavaScript and using a programming language, these languages are built to mirror real concepts, real ideas that we have in the real world. And particularly, actually, once we get into our next module, I'll really try and start to bring that home with some of our other data structures we're going to talk about. But in our regular life, we have some routines we follow. Right, when we start our class, we have one, right? So we'll start a class, we do a little icebreaker. I usually pester everyone to send me something, right? And then we get into our content and we start to go through slide after slide until the very end, and then we have our lab. So even that is sort of in its own little routine. So in programming, we're talking about for loops, but we're talking about, or I should say loops in general, iterations. We're talking about adding sort of that structure of, okay, we want to start with something, we want to continue doing something, and we end with something. We want to add that kind of structure into our programs. All right, so a loop in programming is like a repeated set of instructions. It's a way for a computer to do the same task multiple times without having to write the same thing over and over. It's like telling the computer, hey, do this, and then do it again, and keep doing it until I say stop. We'll look at a couple of examples of where this can be really useful just from what we've already learned, and then we can talk about some other powerful examples in the future. So let's consider a technical example of how a developer could use a loop on an everyday job. So imagine a front-end developer working on a web page that needs to display a list of articles. Each article has a title, publication date, and some content. Instead of manually writing the HTML and styling for each article, the developer can use a loop to do the following. You can generate that HTML and apply style for each article dynamically without duplicating the code for each individual article. If there are more articles or new articles are added later, the loop can just easily adapt and adjust to that, as opposed to manually updating the HTML and styling for each one. So using loops allows the developer to efficiently manage and display a dynamic set of articles on the web page, making the code more scalable and adaptable to changes in the content without repeating the same code structure for each article. Now, I don't know if you all have maybe thought about this or noticed this since you all have learned HTML and CSS, but even on a site like this, right, we have a lot of different little pages here, these different sections. How does this show up, right? How does this actually show up on the page? Well, it's not one person going in and the person developing content is going, great, okay, I need to go through and add some HTML and CSS for every single one of these, right? Even if it's just copying and pasting over. Instead, this information of what slides to show next is probably stored in some kind of data structure and then iterated over to display all this information one after another. And that's going to be a case for a lot of things that I think we kind of take for granted on the internet. If you all using social media sites, we're able to like endlessly scroll. That is some data structure, data being iterated over, and each post is getting shown to you one after another. We were on the Code Wars site, if you all remember. I'll try and pull it up as I'm talking about it. Hopefully it won't take too long. For each of the different challenges that we had, there's a bunch of different, it's going to take too much. There's a bunch of little icons next to each challenge. Those icons are probably not hard coded there. Instead, they're probably looped over and each one is displayed. So loops are really essential to being able to build robust, interesting websites and not having to manually go through and copy and paste multiple HTML lines or something like that. So really quite powerful. All right, so here is our for loop in JavaScript. There's a lot of symbols here, and don't worry, we're going to talk through each one of these. A for loop, this is a type of iteration, a type of going over something, is a loop that it repeats some block of code a fixed number of times. And it's particularly useful when you know the exact number of times you want a specific set of instructions to be executed. Right, so when you know how many times you want some instructions to be executed. To break this apart, so see, we start with the for keyword over here, and actually make this a little bigger. We start with the for keyword over here. We then have parentheses after the for keyword, and we have a bunch of content inside. I'll talk about that in just 1 second. We then have curly braces, and then we have a block of code or multiple lines of code that we can place within those curly braces, and that is the code that we run multiple times. So if you can ignore all the stuff within the parentheses for a second, the structure, the basic structure, looks kind of similar to our if statements, right? Where we had an if keyword, we have parentheses, some stuff goes in between, and we have our curly braces. So that block of code portion is very similar. So that's one thing we sort of hang our hat on there and sort of identify. What goes inside the for loop are 3 different parts. Let me go ahead and just scroll down. We can take a look at this. So the first part is initialization. So you start by setting up a variable to a specific variable. And this variable is going to be used throughout the loop to keep track of how many times it is running. If we take a look at our example here, we'll see we have let I equals 0. This is a very typical way to start a for loop. I represents the index overall. You don't have to put I here. You can put any variable name. It doesn't matter. But in this case, we're setting up a new variable called I and setting equal to 0. The second part is the condition. So we're going to define a condition that must be true for the loop to continue. The loop will keep running as long as that condition is true. So in this case, when we go up here, as long as I is less than 5, we're going to continue to run the code within those curly braces. All right. And since it starts at 0, right, it should begin running immediately. The last part here is our iteration or incrementer. We need to do some kind of action that's going to get run at the end of the loop, and it should modify that initial variable that we set up. So in this case, and this is again quite typical, we have here I plus plus. Remember what plus plus does, right? It's going to increase the value of I by 1 and store it within that variable. So how this block of code will work is we set I equal to 0. I is less than 5. That is true. Because that is true, we'll run the block of code in here. At the end of that block of code, I will increase by 1. And then I will be 1. 1 is still less than 5. And we continue onwards until we finally get to a step where I is no longer less than 5. All right, so again, 3 parts within that for loop. Notice how they are separated by semicolons here. These semicolons are non-optional. So whereas the semicolons at the end of our lines of code, we talked about before, those can be kind of optional. In this case, they are non-optional. You need all of these semicolons. And there's sort of 3 different sections, right? First, we set our iterator, we then set our condition, and then we iterate at the very end of the loop. All right, I threw a lot of words at you. Let's see if we can get to an example and actually see how this goes. All right, so let me copy this over, make this a little bit bigger. Hopefully you all can see this okay. All right, so let me go ahead and let me just run this code first, and then we'll talk through it. So you can see over here, I pasted the code in, clicked run code. Our code showed up on the right-hand side here, the output, I should say. So we're running script.js, that's this file. And then we see the output here is 1, 2, 3, 4, 5. Okay, so let's see how we got to that. So for our for loop, we have our for keyword. We need to set that up. And then we have our parentheses. We'll talk about everything within the parentheses in just a moment here. The block of code that we're going to run on each iteration is this console log statement. This console log is going to print out the I variable, right? So at every step of the loop, we're just printing out the I variable. I can, of course, adjust this. So for example, I wanted to say iteration, perhaps, as part of that. We can rerun this, and we'll see this. These changes occur. How this works inside of here is we first declare a variable. In this case, we're saying I is our variable, setting it equal to 1. Our condition is while I is less than or equal to 5. And then at the very end of all of our blocks of code, we're going to say I++, which is going to increase the value and set I to that new increased value, right? So the first time through, I is 1, I is indeed less than or equal to 5. So we print out iteration 1. At the end of this block of code, we then increase I by 1 and reassign it to that variable. I is then 2. 2 is still less than or equal to 5. So we print it out again, so on and so forth until I is equal to, we'll do this last one. So I equals 5. I is indeed less than or equal to 5. We print out iteration 5. I increases, I is then 6. So because I is 6, that is no longer less than or equal to 5. And then we move on. That for loop is complete. So it just keeps iterating until that condition ends up being false. And that is a for loop. Just like with an if statement, you can put as many lines of code in here as you would like. So if I wanted to, let's say, add a little break in between here, clear this out and run it. Right, we can see we can run as many lines of code as we want in here. All right, let me pause here. Any questions on this so far? It always sounds fine as long as I'm just explaining it. All right, good. Okay, excellent. Let's just play around this a little bit, and I want you all to tell me what you think will occur. So if I change this number, this variable, to 3, so I from 3, what do we expect the output to be? How do we expect the output to change from printing out 1 through 5? What do you all think? Oh, I see that several people are typing. Love it. Let's do it. Yeah, excellent. Right. So what we should see is something like 3, 4, 5. So we're starting at 3. We're going to keep going until it's less than or equal to 5. Excellent. How about if I update this condition part to say while I is just less than 5 as opposed to less than or equal to 5? How will that change it? Yeah, we're cutting down, right? We're sort of making the range here smaller. Excellent. All right, let me make a couple adjustments now. I'm going to set I back to 1. I'll say I is less than or equal to 5. And then over here, I'm going to say I plus equals 2. What do y'all think? How is that going to change the output here? How's that going to change the output? I know this one's a little bit trickier. First couple weren't too bad. All right, we got some fun guesses. Let's take a look. Yeah, 1, 3, 5, right? Because we start at 1. 1 is indeed less than or equal to 5. We've run that first one. And then we increment by 2 as opposed to by 1. So we're going to skip over the value 2 and go to 3. We can print that out. We go to 5. The next number will be 7. 7 is not less than or equal to 5. Excellent. Right. Let's do one more change here. What if I just do this? What do y'all think? What would happen if I just do this? I plus 1 is indeed different than I plus equals 1. So what do you think if we just do I plus 1? Right, Amar says, oh, just print 1. Sorry, saying 1, 2. All right, let's do it. Let's do it. Let's hope my computer doesn't explode. Huh, huh. What's going on? I think I probably have to refresh this now. Oh, no. That is right, trackers. We now know how to create an infinite loop. So what happened there? My terminal just kept saying iteration 1, iteration 1, iteration 1, iteration 1, iteration 1, iteration 1, iteration 1. Right? So the condition is always true in this situation. Condition is always true because I is increased by 1, but it's not stored. That value is not stored. So I is just 1, 1, and it means the loop keeps running. So that's something we have to be a bit careful about. It is possible for us to create an infinite loop. And what that means is our condition is never met in the sense that it always is true. It never returns false. Do not run this code. You have to refresh your, your browser as well. So the example we have here, this is a similar situation. So here we have I equals 0, and the condition here is while I is greater than or equal to 0 and I plus plus. This means I will just keep increasing. That condition is always true, and so we're constantly just going to be logging out console log, console log, console log. This is an infinite for loop, right? This is not uncommon, particularly when you all are just learning loops, if you're trying to play around with the structure of it. So it's not necessarily a bad thing if you hit it while you're programming. But we of course want to avoid this because what this does is it blocks the rest of our program from running. If I actually go back over here, let me go ahead and write this correctly so we don't get that. You know, our for loop is going to show up in between the rest of our code. Not every line of code will go within a for loop. So I can write code around this, of course. If we go down here and run it, right, we have our start, we have our end, console.log statements. If we have an infinite loop, we will never reach this line down here. It's just going to be stuck within the for loop. And of course, we've written a bunch of code below we want it to run, right? So this is something to be avoided as best as possible. And yes, as it says here, creating unintentional infinite loops is a common programming mistake and should be avoided as best you can. If you're working within Codio, you can often just like refresh the page. That'll solve the issue. Sometimes like Control-C will work depending on if you're working in a terminal or something else. It might be slightly different. But there's usually always a way to exit out of it. So no stress. It just happens sometimes. All right, now it's time for me to pass it all over to you. So we've gone through an example. We've talked about the perils of infinite loops. Here is your challenge for the next few minutes. So we want you all to calculate and print the sum of the squares of the first 5 natural numbers. So what it's going to look like is what's 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. And I want to use a for loop to iterate through the numbers and accumulate the sum, log the final result. So that's what we're trying to aim for. It's feels a little mathy maybe to start. But what I would do is go ahead and first, if I was going to do sort of multiple steps here, I would say write a for loop that goes from 1 to 5, right? That's probably the first thing we want to do because we're going to use those numbers. Second thing I might do is sum up all of the numbers and print it out at the very end. You can figure out how to do that where you're looping and adding and printing out. Then that would be nice to square all of the numbers before adding. So if you're struggling with thinking of where to start, that is how I might go about doing this. All right, let me pass it over to you all. Let's spend a couple of minutes doing this. I'll get a timer up. We'll say 2 minutes to start. If we get to the end and you all are done, then great. If not, any more time, just let me know. Go for it. All right. I see we got one solution already thrown in the mix. I think I'll go ahead and get started, but I'll go pretty slowly. So if you're feeling close to getting a solution, feel free to ignore me. You can always check back in just a moment. So I'll just talk through my thought process in terms of how to solve this, and we'll follow these steps up above. So the first thing we need to do is we want to write a for loop that goes from 1 to 5. So first, I'll go ahead and write my for loop. I'm going to put the structure of it together just to start. And I'll go ahead and be a bit more verbose here as opposed to using the single letter variable I. I'm going to type out index here. So first of all, I want to declare my index variable, set it equal to, I did 0 just by default, but we should set it to 1. And then our condition, we want it to be while this is less than or equal to 5, right? So we want to count up to and including the number 5. And then we use our I++. Go ahead and log this out. Let me put this variable name. Let's go ahead and start here. I would definitely encourage you all, as we start to get to some more complex problems, really do your best to try and break up the problems like this. Sometimes once you get a lot of practice, it's easy to kind of just go in and be like, great, I know exactly what to do. But particularly when you're starting, trying to make these challenges a bit smaller in scope can really help as opposed to trying to tackle everything at once. So this is already looking pretty good. We're able to print out all those numbers that we need. The next thing I think we should probably do is try and sum up all these numbers and print it out at the very end. Now, there's a couple different ways we could try and do this. I'll show you the way that's going to work here. So above the for loop, I'll go ahead and define a variable called sum, and we'll set this equal to 0. This is going to be sort of our starting value here, right? Inside of here, what I want to do is sum plus equal. In this case, we'll just do index. And let's go ahead and print out the sum at each step, and then we'll print out the sum at the very end as well, just so we can see everything that's going on. Let's go ahead and run this code. All right, so we see here we're adding the indexes each time. So 1, 3, 6, 10, 15 at the very end, we've added up for 15. Cool. So this is pretty nice, right? This is getting to be pretty clear overall. At each iteration, we're increasing that sum variable at each step and increasing it by the index here. There's a couple other things you all might have tried to do and maybe got some kind of issue. So one thing you might have thought to do is inside the loop, let's define the sum, and then we'll go ahead and add it. Of course, why is this not going to work? Well, it's not going to work for a couple of reasons. Let me go ahead and run the code here so we can see the error. Excellent. So there's a couple things that are going to happen here. The first is that each time this loop starts, we're just redefining sum, right? So sum is going to be 0, sum is going to be 0, sum is going to be 0, and then we're adding just the current index to it. So even if we didn't get this error right here, we would end up with the problem because we'd only ever really add the last number. It wouldn't really quite work like that, right? The other problem we're encountering is that it says here sum is not defined. And that's happening right down here with console log end. So the reason this is happening is it has to do with an idea called scope, which is a bit tricky. And I believe we're going to talk about it more with the functions lesson. But I just kind of want to give you a little bit of a preview here. Essentially, this variable let sum only exists within these curly braces. That's the way to think of it. So whenever we're doing something where we're accumulating, we're using a loop to modify, accumulate, change some other kind of variable, we always want to define that up above it. And again, we'll talk more about this as we start to learn about functions and the different types of scope. But for right now, just keep in mind, if you're wanting to keep track of some variable value, you probably want to do that perhaps outside of the for loop. So that might have been an issue you all might have gotten. The last step we want to do is we want to square all the numbers before adding. So to do that, remember, there's actually a couple different ways we can square stuff, but we can use the 2 asterisk symbols and 2 afterwards. That'll square all of these values. You could also do something like this as well. That would work as well. We run this code, we end up with a final result at the very end of it. And that is our loop. So notice here, we actually don't have to have any console logs in the loop, right? We're just doing some arithmetic. We're just doing some basic math stuff inside of here. We are adding and reassigning those the products of those evaluations to the sum variable and printing out at the very end. Take a look at the solution that they have over here. It is indeed quite similar to what we have. They've set up an additional variable here, which, yeah, that's not too bad. I like that. That works just fine as well. Any questions about this solution or how we got here? Feeling good, folks? Okay. All right, excellent. We can go ahead and move on. So we just talked about a for loop. So for loop, I would say, is going to be, 80% of the time, 90% of the time, you'll end up writing a for loop when you need to loop and use one of these basic loops. We do have another kind of loop, though, which is called a while loop. A while loop will look like this. It actually kind of needs all the same parts that a for loop does, but just sort of looks a bit different. And a while loop can be good, particularly in situations where you may not entirely be sure how many times a block of code needs to run. It may be the case that you always want it to be running or have a precise number, but it can work a bit better in situations where you're not sure how often you want to run. To be clear, you can write for loops as while loops. You can write while loops as for loops. These are just two different tools that do something very similar with a slightly different syntax. So if you look at the syntax here, it's very similar to what we saw before. If anything, maybe a bit more explicit. So first up top, we initialize some variable and value. So in this case, we're saying let I equals 1. That's above the actual while loop. We then have our while keyword. Within the parentheses, we just have one condition. And our condition there is whenever the condition is true, the code within the while loop will continue running. We then add all of our code to the while loop that we want to keep running. That'll go within those curly braces. And at some point, usually at the very end, but at least at some point, we will need to modify that initialized variable to help make it so that at some point, this while loop stops running. So you can kind of see all the different components here of the for loop. They're just broken up in slightly different ways. Right, so let's take a look at this example right here that we have. It's a tiny bit bigger. All right, excellent. So this is something very similar to what we saw before. You can see right here, we're defining a variable called I, setting it equal to 1. And then we have our condition in here, which is while I is less than or equal to 8. Go ahead and do something. That something we're going to do is run our console log statement, and at the very end, increase I by 1. Okay, so while loops are probably, I would say, much easier to end up in an infinite loop because it's just easy to forget this last little bit here where you modify the iteration. But you need all of the components of a for loop. They're just going to be sort of spread out a bit. All right, so it works very, very similarly. Right, let's take a look at another example. So here, this is basically the same, except we changed it so that I is no longer just the variable I, but instead a counter of some sort. So we can run this, it works exactly the same. But just to note, again, you all can define these variables as whatever you want. Often if you're looking at code online or sort of looking for help with something, I is sort of the easy fallback. These can be called whatever. And whenever you're writing code, you should try and make it as clear as possible as to what it is your code is trying to do. All right, now we're going to pass it over to you all. Let's talk through this little exercise and challenge. I think it's a kind of interesting one. So as you'll see up here, we have our prompt library that we're pulling in once again, when you all have been having so much fun with, right? And here we have, we're accepting some user input. Our prompt is going to be enter a positive integer. And then we're going to try and parse that value and assign it to this value number. We then have this little conditional statement here. Often if we have a condition right at the beginning to sort of kick us out of the process in case something's gone wrong, you might refer to it as a guard clause. You might hear me saying something like that. This is checking, hey, if this is not a number or the number is less than or equal to 0, then go ahead and just print out, hey, this is an invalid input. Please enter a positive integer, right? So this is a nice check for what the user input might be, because again, the users can put in whatever they want. If that is not true, to put another way, if the user enters in a correct positive integer, what we want to do is we want to write some code that will use a while loop to sum all numbers from 1 to that number. And then it's going to print out the sum. So your task is to do a couple things. First, you're going to make sure to define this variable right here, sum. That'll need to be defined somewhere within this code. And then you'll need to use a while loop to count from 1 to that user inputted number and add all those numbers together. So similar to what we did before, but just a little bit different. That's the plan. I'll give you all, we'll say like 3.5 minutes, 4 minutes. This might feel a little bit trickier to try it out. If you get to a good spot, give me a thumbs up or go ahead and paste your solution in, your output. We'd love to see it. And then we'll come back in just a few minutes. All right, good luck. You can do this. Right, y'all. I'll go ahead and get started. But if you're at a good spot and you feel like I'm almost done, please feel free to continue on. You can always check back in a minute. All right, so let's talk through how to do this. So what we want to do is we want to make sure we have access to some counter that we're going to increment. We need access to that number, and then we'll need access to a sum as well. So there's a couple things I can set up here. I'll set the sum equal to 0. Let's go ahead and set a count or index equal to 1. I'm going to set up our while loop. Sort of put the structure right here. And we're going to use count as our way to figure out when we're done with the while loop. So I want to have that count plus plus. So the condition here should be something like while count is less than or equal to the number, right? Because that number should indeed be a positive number. And we're going to count up to and including that number. So inside of here, then what we want to do is sum plus equals the current count. That should start as counting from 1. The next time through it should be 2 plus 2, so on and so forth. So let's go ahead and run this. We'll see where we're at. Perhaps I've forgotten something. Let me restart this so it looks normal. Go ahead and run it. All right, enter a positive integer. Let's start with just 1 to see what happens, right? So we can see here some of the numbers from 1 to 1 is 1. Nice. Seems like it's going well. We'll slowly increase here so we can test our output. This looks like it's going good, right? It's 1 to 2, so 1 plus 2 is 3. And now if we add a larger number in here, I mean, it seems pretty good to me. Any questions on this code or how we got to this solution? Any questions here? All right, it's starting to get kind of tricky. Yeah. A few weeks ago, we were just defining some variables and printing out some strings, and now we got conditionals, we got loops going on. And what I really like about this example that can feel maybe a little bit overwhelming is that we can see how all these tools are trying to merge together to create a more interesting program. So we can see how we're pulling in the prompt. We can see how we're using our parse int to forcibly convert between different data types. We have our conditionals here. We're using if and else. And we're using our logical operators to check between different values. And within our else case, we're then nesting a loop inside of here to perform some kind of functionality as well. And of course, we have some string interpolation down here, our template literal with our backticks. So this is starting to look much more like a regular program would, and that we're pulling all these various tools together all at the same time to create something a bit more interesting. And just think, this is only 19 lines of code. Just wait till you're writing 100, 200 lines of code, just flowing freely. You're gonna feel like Mozart, just typing out some really interesting programs. All right, let's move ahead. All right, so just for a brief moment to compare here. So loops allow us to execute the same code repeatedly until a condition to stop the repetition is met. They're a fundamental tool in web development, can be used for various purposes in coding. Refactoring code using loops can make it much shorter in length. I'll also add here that we've learned about these loops in JavaScript, but this is a concept in every single programming language in terms of iterating over. So this is a good foundation in general just for programming. So when you're trying to decide which kind of loops to run, as I discussed, for loops are generally best suited when you already know how many times the loop should run, while loops are more appropriate when you want to stop the loop based on some condition other than the number of times it might want to run. Now, let me just check something here. We don't really have an example that goes into this, but a lot of, if you want to like a little game or something like that, where you're constantly asking the user for something or asking them to make choices, often you actually might rely on something like a while loop, where the condition is, is the game over? Did the user lose all their lives or whatever it might be, right? You're just going to keep running through the same gameplay loop until some condition happens. Not, I'm going to run through the gameplay loop 4 times, right? So that might be a situation where you would use a while loop. All right, let's talk about the break keyword before we get to our actual real life break. We'll talk about the break keyword. So the break keyword is used to terminate the execution of a loop prematurely. It's often used with while, for, or switch statements to exit the loop or switch block before its normal completion. So we've seen break before. This is an opportunity for us to stop the execution of the thing we are working on. So just a quick example here. This is kind of just a general toy example. And so what this is doing is we'll run this code. And this code is starting a while loop appropriately. Right, we're going to loop over some code. We're going to print out the current iteration. But we have a check here where if at any point I is equal to 2, we're going to go ahead and break and just go ahead and stop executing the entire loop. So it kicks us out of the while loop overall. And we can see on the right-hand side here, 0, 1, 2, that is what is printed, but we don't get any further because we've broken out of it. I'll say right now, we're probably not going to see too much of break until there's we have more data structures and things to loop over, but it's good to know if you want some sort of situation where you want to break out of your loop. And although we're showing it with a while loop here, it does indeed work for for loops as well. All right, that was our quick aside. Now we're talking about nested loops, and then we will have our breaks. We're doing pretty good on time here. I'm going to spend a little bit of time on this because nested loops can quickly get relatively complicated. It doesn't take too much for them to be a bit overwhelming. So the idea of a nested loops, remember when we talked about if statements, we were able to do sort of an if-else, and then within one section of that, we could do more conditions, right? And sort of nest things. You can do the same thing with loops. So let's take a look at this example here. So there's a couple things you'll notice. In this case, this is going to create a single multiplication table. Well, we have 2 different variables that are defined up here. So we have I and we have j. Each of those start at the value 1. And we see the size here is some additional variable we've asked for outside of the loops. And we're going to keep iterating those up until we reach that size. And each of these is going to increase by 1. There's no particular code besides the loop inside this outer loop. The only sort of statement code we have is within this inner loop. So let's take a look at what this output looks like. There we go, got our times table. All right, so let's talk about what is happening here. So first of all, you might notice a bit of a pattern. We take a look at the content over here. We'll see that the first number here is always 1 for 5 times. And then we have it as 2, 5 times, 3, 5 times. So what does that mean? What is it referring to? When we look at the output here, our console log output is I plus this little asterisk plus j plus equal sign plus I times j. I know it looks kind of nuts. We can break this apart pretty easily. So the first big loop, right? First big loop here, we have I equals 1. So that means for every iteration of this inner for loop, I is going to be equal to 1. And we see that over here on the right. Right? This is what I is for each of those 5 iterations. We begin our for loop, I is equal to 1. And then we have our inner for loop, j equals 1, and j is going to keep running while j is less than or equal to the size. So that means the first time through, j is 1, and we will go ahead and multiply those numbers times each other, right? And then on the second iteration, we are still on the second iteration of the inner loop, not of the outer loop, right? We are just in the iteration of the inner loop, not the outer loop. And so that means I remains the same, whereas j then increases by 1. So we're slowly going to increment up until the inner loop's condition that j is less than or equal to size, which is 5. Once that completes, we then finish out this for loop, and then we get to our outer for loop is going to make its next iteration. Right, so our outer for loop is doing one thing, and while that's happening, our inner for loop is counting up each time, right? It slowly starts to increase from the outside. So we have it starts at 1, we do 1, 2, 3, 4, 5, do 2, 1, 2, 3, 4, 5, 3, 1, 2, 3, 4, 5, and so on. So we have our inner loop and our outer loop working together in concert to print these different values out. We can, if you're ever getting confused as you're going through loops, I recommend you just try and write some sort of logging statements like these. Sorry, and I put this wrong. Say outer loop I, and we can say inner loop here. I can type this correctly. Goodness. J. Sometimes something like this can help clarify, even though you end up with a lot of output, at least kind of see where you're at any given point. So we can see we're in the outer loop 1, inner loop 1, that's where we get 1 times 1. And then notice that we just see inner loop, inner loop, inner loop until we get to outer loop again, right? So we can track sort of what's happening within the program. Whew, all right, let me pause there. Any questions on this? Any questions here? Okay. I mean, it's easy, right? Just easy. No problems at all. Totally straightforward. I do know like this can start to get kind of complicated just trying to read through this. So for example, I would say this console log, feels a little overwhelming, right? So one thing I might do if I was trying to make this a bit more clear for myself is I might actually change these variable names. So maybe we change this to outer, right? And we can change from J to inner. Get these little console log statements. And then here, we might actually maybe set up some new variables. So you can say inner plus outer. And then our console log statement here, say outer plus inner plus some. Actually, it's your product, right? I'm sorry, I'm mixing up my various multiplication things. To me, this probably reads a little bit clearer just in terms of trying to read through this code and understand what's going on, as opposed to just I, J, K, which at a certain point can start to feel like, oh my gosh, I don't know what's going on. As code gets more complicated, using single letter variables will only make it worse, right? So if this is feeling confusing, I'd really recommend, being really clear with your variable names. Longer variable names can feel like a pain to type out, but it will save you time as you're trying to work through a more difficult problem. All right, no questions. Let's move ahead. All right, so as it says here, so in conclusion, nested loops add complexity to programming logic, which can be challenging even for experienced programmers. I would say I will often start typing out stuff, run my code and be like, oops, I used the same variable, or I forgot to log out this part, right? So it's easy to forget. But the idea is it allows us to, first of all, just do some more interesting things, be able to loop inside of loops. And it's really helpful to sort of percolate the idea right now, because as we get into data structures, we're going to want to use nested loops pretty concretely, which we will talk about, I guess, at the end of this week. All right, so that is loops. Not too bad, right? We're just iterating over stuff. We have 2 different ways to do it. We got our for loops and our while loops, right? And for the most part, we're going to stick to just those 2 definitions there. We also learned about the break keyword and saw how we could use nested loops to create some more complex code and loop multiple times. We're going pretty quick here, so let's go ahead and take our break. We'll do a 10-minute break. Go ahead and take a moment to rest your brain, stand up, walk around for a moment, pet your pets if you got any. When we come back, we will then talk about our lab where we have a few different challenges to get to. All right, that's it. See you all in 10 minutes or so. And then I guess C1 staff, can we pause the recording here? Oh, you're on it. Apologies. Right. Hey, folks, welcome back. Hope we all had a nice break. Gonna walk around for a brief moment. All right, let's go ahead and talk through the different lab challenges we have today. So I'm gonna talk through each of them one at a time, and then we'll give you all probably about 15, 20 minutes to work on them. And then once we have done that, we'll come back and I can walk through the solutions for these. We'll probably end a bit early today, just given the content. All right, so for this first challenge, all right, sorry, it's always a challenge figuring out how to make sure this is big enough so you all can see, but also squished enough so I can read it. All right, so the plan for this one, in this challenge, will be taking control of a spacecraft countdown sequence and refactoring it to achieve countdown excellence using the mighty for loop. So we can see over here on the right, we have some code that's going to print out a countdown, right? So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. We want to refactor that code, but what we mean by that is rewrite this code so that instead of having these duplicate console log statements, we have just a single for loop that's going to count down from 10 to 1 and then print blast off. All right, there's a couple different ways we can do this. So definitely feel free to be a bit creative in your solution. So that is the first challenge. Second problem to start is we're going to use a while loop to transform some code. We want to change this code over here that just says start, end, and then a bunch of processings in between to instead use a while loop. So the instructions here ask you to say this processing message 7 times. I think that's a good first thing to start with. So replace these duplicated processing const.logs with a message with a while loop that will do that 7 times. If you get to the end of this and the end of the next challenge and you're feeling good, maybe come back to this one and figure out how to randomly print the processing message, perhaps between 5 and 10 times, something like that. So that could be a little stretch challenge for y'all. So as a second challenge, this one again with a while loop. This last one is just a chance to practice using the break keyword within a loop. You can write a for loop. It's going to count up from 1 to 8. You're going to print the current number for each iteration and introduce an if statement inside the loop to check if the current number is greater than 5. If the condition is met, use the break statement to exit the loop immediately and print some kind of break message. So just some practice on using that break keyword. So again, that's 3 different challenges here. First one is to refactor this blast off countdown. Next one is to refactor this code. So instead of having this duplicate processing, you're just having it print out a few different times using a while loop. And then this last one is using a for loop to do a count, but that breaks out at a certain number. That's it. Any questions about the challenges? All right, we'll see how it goes. So we'll say, I'll give folks like 15 minutes to do this and check back in. If you get to a good spot, you're feeling done, go ahead and give me a thumbs up in chat or post some of your output to let us know. And assuming that a few folks have gotten done by the allotted time, I'll start to go through from problem 1 to the very end, and we can talk about the solutions. That is it. All right, if you have any questions, let us know in chat. Good luck with this lab, and we'll see you in just a bit. Right. Welcome back, folks. See, a lot of you have been posting your solutions in live chat. Much appreciated. It really helps me figure out sort of where folks are at. So let's go ahead and I'll walk through these quickly. You all thankfully have a lot of examples to look at thanks to your fellow classmates. But I'll talk through some of the solutions here and then we'll wrap up for the day. All right, so our first problem here, so this should have felt very familiar to the other examples we've worked on today. The only difference though is that we're decrementing instead of incrementing, right? So we can see here, one solution here is to set our variable equal to where we want to start, which is going to be 10. And then at the end of each iteration, we're going to decrement by 1. This is going to stay true as long as the number is greater than or equal to 1. And finally, you put this console log statement outside of the for loop, so it's not involved in the loop at all. So we can run that code. You see we get the nice countdown and then blast off at the very end. There is a lot of variation as to what you can do inside of a for loop. Everything broken up by these semicolons can actually be much more complicated. Your conditions can be much more complicated. This is just, this last section where we're incrementing values. It's just code that runs at the end of the loop. So we could do all kinds of things in here. In general, you'll either be incrementing or decrementing, but you can always sort of change up how you are looping through different content. All right, that is our first one. Not too bad, just flipping the order of iteration. Our next one here is asking us to use a while loop to determine the number of processing statements that come out. We'll see here it's going to be pretty similar to what we've seen before. We have some console log statements above and below for start and end. And we set up some kind of counter. Again, this variable can be named whatever you like. We'll set that equal to 0 to start, and then set the counter that it'll keep running, this code will keep running as long as that value is less than 7. And then we just say counter plus plus. If we want to do something like want to start from 1 less than or equal to 7, that is the same number of times. Just depends on how you want to figure out the conditions and your starting value. Remember, this value is quite important. This line is quite important. If we forget the counter plus plus, we're going to end up with an infinite loop where it just looks like we're processing forever. So if we run this code, we can see we got our start, we process a number of times, and then we end. So again, very similar to what we did before. And in this final example, again, quite similar to what we've been looking at in the past, we have our for loop set up to go from 1 to 8, and we're going to print out that number. But as soon as I is greater than 5, we're going to log out a different statement and then go ahead and break out of that for loop. So as you can see, it works as expected here. All right, so all in all, I think not too bad for these different challenges, but as you're starting to see, we're starting to really leverage a lot of the tools that we've learned, whereas before it might have felt in the past each day was sort of nice and sort of encapsulated in its own little realm. We are now really having to combine a lot of the skills that we've learned together, which is normal. That's what this process is like. I'll say as well, as we continue to add more and more tools, there is more and more room for syntax errors. And so that means, forgetting a curly brace somewhere. It means, forgetting one of these semicolons, or maybe using the wrong word, a small, typo, maybe you use I up here, but then you just type out J somewhere, right? These are the kind of things that can cause errors in your code. And again, once you get errors, it's not something to be scared of. It's just something to use as a diagnostic tool to figure out, okay, where did I go wrong trying to put this together? So I am sure as you all start to continue working on these kinds of challenges, you're going to start to come up against more errors as you're just trying to solve the challenge. Again, that's a normal part of the process. If you are the one person who can write code with no errors for your entire career, I would love to shake your hand in person. All right, so it's just part of the process overall. All right, just if this is feeling pretty good, but you want a little bit of a stretch, just a couple stretches for these. I would say something fun to maybe learn about, and I'll post something in the resources channel on how this works, is maybe to add a bit of randomness to some of this. You can add random numbers in here to maybe say, for example, this second example that the number of times it says processing is indeterminate, right? As opposed to always being 7, maybe it's 3, maybe it's 5, something like that. That could be a way to sort of learn a few new things about JavaScript and practice your skills. You can also consider practicing, again, sort of counting up and down from different values given by perhaps a user. So adding prompt perhaps into this first example and trying to have it count down from whatever number the user gives it. So, as we go through these labs, it's easy to sort of be like, great, I'm done. Let me just go ahead and stop. One of the best ways you're going to learn is by playing around, trying to add new features to these simple little programs that'll really stretch your brains and make sure that you're really getting into your fingers what we're learning. All right, and I've made a pretty short lesson for a pretty complex topic. So we've completed our loops iteration lesson. So some of what we did today, we dove into the intricacies of loops, mastering both the while and for loop constructs. We've learned about break statements, an essential mechanism for prematurely exiting loops based on specific conditions. We explored what happens if you develop an infinite loop and how they can stop our programs from running. And hopefully you have some insights into the decision-making process of when to use the different types of loops, and of course, some comfortability using both of those. So tomorrow we're going to be going over a project. We're going over the project from last time. Just checking our schedule here. Yeah, much of that project. And then we will move on to talk about some more complicated data structures at the end of this week. As always, we're going to continue to build upon the things we have just learned. So if this is feeling a bit tenuous, I really encourage you all to continue practicing with it. There's a couple of good places you can practice if you're looking for that. I've talked about Free Code Camp before. That would be a great place to go. Core CodeWorks is a good place to practice. Perhaps if you're trying to work on some challenges and really leverage these skills, that could be something to look at as well. So don't feel like you don't have anything to work on. If you're ever feeling like you want more practice, please do just let us know in live chat or resources so we can send you off to something. I think I'll stop there. Are there any other questions about this lesson or anything about the project that's due tomorrow that you all have before we close out a bit early for today? Any questions? Okay, cool. How about this? How are folks feeling about loops? Feeling good? Feeling nervous? Feeling excited? Awesome. Thanks, Omar. All right. Thanks, Timo. So far, so good. Glad to hear it. Yeah, Tatiana, cool, but afraid of forgetting them. Need to practice. Yeah. Don't worry. We'll get you lots of practice, but make sure you're seeking out practice on your own as well. All right, excellent. Glad folks are feeling good. If you have any questions, do let us know. But with that, I think we'll give you all some time back. See you